Okay. In previous courses, like last year, we did trig. And I told you in grade 10, you guys can only do trigonometry if you got one of those. What's that thing called? Yeah. You don't do trig in grade 10 unless you have a right angle triangle. You guys are going to be able to do trig on any shaped triangle. You don't need a right angle. You do that with sine law and cosine law. But first, okay, I'm going to do 4 days of grade 10 in about 5 minutes here. Okay, this is review. Review. Determine x. Okay, what ratio are we going to use here? I know this SOH CAH TOA stuff. How do you know which one to use? Well, you figure out what you're given. In this triangle, that's the hypotenuse. It's always opposite the right angle. This is the angle I'm talking about. That's the opposite. And here, that must be the adjacent. Okay? Label your triangle. What ratio do I want to use here? Which ratio has O and H? That's what I'm given. Sine. The sine of x is O over H. If you don't know the angle, what button are you pushing on your calculator? Inverse sine -1 of 8/14 will give you the angle, and that one is 35 degrees. And then kind of look at the picture. Usually they're written accurately. Does that look like about a 35-degree angle? Sure. Check. Okay? If you got 2 degrees, you got to ask yourself, that doesn't make any sense. If you got 0.684, doesn't make any sense. Okay? That's finding an angle. Same thing we're going to use an aside. If you got a right angle triangle, I'm going to emphasize this because after doing sine law, cosine law, I'll give you one of these on the test, and everybody will be using sine law or cosine law, and you'll forget about like SOH CAH TOA. If it's a right angle triangle, why bother doing anything else other than SOH CAH TOA? Okay? Pretend you're back in grade 10. Here's my triangle. X is the hypotenuse. For this 40 degrees, that's the opposite. So this 19, that's the adjacent. What ratio do you want to use? Well, which one has A and H? Cosine. So cosine of 40 is A over H, which is x. How do you solve that thing for x? Algebra tells us, I want x. I want x by itself. It's down here. How do I get it up in the top? How do I make it a numerator? Multiply both sides by x. X divided by x. Now it's on the top. No more fractions. Okay, let's write that in 2 steps. But x isn't by itself. How do I get rid of cosine 40? Yeah, divide it. Whatever you do to one side, do to the other side. So x is 19 over cos 40. Okay, put that in your calculator and you get 25. There's no units here, so it's just 25 units long. That's a length, right? That's the side. So now what's the shortcut? I also told you this in grade 10. Essentially, all you're doing is swapping this one and that one, aren't you? Okay? So you don't have to really do this algebra every time. We should understand that. We're in grade 11 pre-calculus. But if you just change this and this, x is 19 over cos 40. Okay? X is 19 over cos 40. Just a little shortcut. It works. It's kind of like half cross multiplying, right? Okay? Any questions on that? Okay. I'm going to skip this one because we just had a quiz. Let's go right to the proof. Why does this thing work? Well, if you were given just this in grade 10, you wouldn't know what to do. And I would have told you something like, well, where can you draw yourself a line so that you make yourself a right angle? Because that's the only trig you guys know how to do. Well, there's a line, okay, to make yourself two right angle triangles. Show that this is equal to this. This is sine law. So let's just kind of, it's already mostly laid out for us. Okay? The sine of angle A is opposite CD, okay, over hypotenuse AC. Right? Okay, but AC they're calling B, so I'm going to say that CD over B. Okay? Now, so CD, how do I solve this for CD? Let's multiply both sides by B, and CD is B sine A. Okay? But let's look at it from this point of view. This triangle. Okay? In B, or not B, the sine of B is opposite CD over hypotenuse, okay, CB, or BC, same thing, okay, which is, what's CB? I'm going to call that little a, okay? So I also want to solve this one for CD. How do I solve this for CD? Multiply both sides by A, and CD is A sine angle B. Okay? That's just grade 10 stuff. So if I said to you, well, I've got enough A, B's, and C's. X is Y is Z. If I told you X is equal to Y, and Y is also equal to Z, okay, what can we infer about the relationship between X and Z? Do we think those are equal to? Yeah. Well, if this is CD, and this is also CD, then B sine A is equal to A sine B. Okay? If two things are equal to each other, deductive logic tells us, well then, this has got to be equal to that. In math, we say it's called the transistor property. So I have this little equation. That's this. It's the same thing. That's sine law. If I divide both sides by sine A, that cancels out, and I got sine B over sine A. If I divide both sides by sine B, that cancels out, and what do I have? A over sine A is B over sine B. This guy. Okay? If I did that with the other triangles, A's and C's, I would get the same thing for this angle C. So that is sine law. It's up here. So if you followed that, great. And if not, well, who cares? That's the law. We're just going to use that to solve triangles. It works for any triangle, not just right angle triangles. Okay? Trig is just ratios. Sine ratio is a ratio of opposite over hypotenuse. This is a ratio too. It's a ratio of a side over the sine of its angle. Okay? In this triangle, all the angles are going to be large capitals. Okay? Opposite angle big A is little a. That's this side. Opposite angle C is going to be little c. I'll put a little squiggle on there because that's the one letter. Is that a capital or a small lowercase? It's hard to tell, right? So if you put a little tail on it, now it means a little c. Capital B, opposite that angle is this side, is little b. Okay? So the little letters, these are all sides. The big ones, those are the angles. Sine law tells us, with that little proof, this ratio is the same as that ratio, and it's also the same as this ratio. Okay? These are the same formulas, it's just they're upside down. If you cross multiply these, you get those. It's the same thing. You probably want to use these ones if you want to solve for a side, because it's already on the top, right? If you want to solve for an angle, you probably want to use this form. Okay, let's see what happens. Use sine law in this triangle to determine ACB. So which angle is ACB first of all? Trace it with your finger. A, C, B, that's this angle down here, okay? Look at the middle letter. That's your hint. Well, what's sine law? I know sine of A over little a is sine of B over little b is sine of C over little c. Which ratios are going to help me here? What do I know? In foundations, their visual skills sometimes aren't as good as you guys's, okay? That's part of the reason why they don't do as well in math. I tell them, do this circle stuff, okay? Because this angle and that side, that's the ratio, right? I want to know sine C. Okay, I want to know this angle. That's what I'm trying to find. Okay, I know A, and that must be little a because it's opposite angle A. But B, I know the side for B. Okay, I don't know angle B. So that's your three ratios in visual form, if you circle them like that. All right? So what do I do first here? Can I find, yeah, I know angle A is 110, right? I know A is 9.4. This is what I'm trying to find. But do I know a little c? No, I don't. Can I solve an equation with two variables? No, I can't. So I'm going to have to get this angle first. And then from that, do you know how many degrees are in a triangle? That's going to be my strategy, okay? So this doesn't help because I can't directly, if I was given little c, then I would be able to do this, okay? So what I do know is this ratio is also equal to sine of B over little b. Can I solve for big B? Yes. One equation, one variable, I can do it. How do I solve this thing for B? I need sine of B by itself. How do I get rid of the 6? Multiply it to both sides. 6 divided by 6. Okay. So now at this point, what kind of a calculator do you have? This is sine B. So angle B, I got to take the inverse sine of this. And if you got a good calculator, most of you do, you can put that in just in, you know, just put it in once instead of putting it in, taking the inverse sine. Okay, let me go to degrees. Okay, inverse sine of 6 times sine of 110 bracket divided by 9.4 bracket is, does that look reasonable for that angle, B? Does it look like about 37 degrees? Okay, to the nearest degree, is that my answer? What was I trying to find again? Yeah, angle C. There's always 180 degrees in a triangle. So subtract the other two and we get 33 degrees. Okay? So that one was kind of harder than it should have been for the first example because we couldn't go directly to get angle C. I had to do another step first. Okay? Yeah, let's do this one. A surveyor measures baseline PQ. That's 440. He takes measurements of a landmark R from P and Q, and angle QPR is 46. Which one's that? QPR. Okay? Again, look at the middle letter. Sometimes that helps. P. And PQR is 75. PQR is 75. Okay. What's the question? Calculate the perimeter of this. What do I need to know the perimeter? Yeah, got one. I need the other two. So I'm going to have to do sine law twice. Okay? So, let's not use A, B's, and C's anymore. I don't have any in this triangle. The sine of P over little p is the sine of Q over little q is the sine of R over little r. But remember, I want the side here, not the angles. So maybe you want your formulas the other way. Okay, maybe you want your sides on the top. Doesn't matter, but sometimes it's a little easier. Okay, it's just one less step when you're doing your algebra. So where do you want to start? Which one do you want to do first? Okay, RQ, which is, do I want to call it RQ or do I want to call it something else? Yeah, I want to call that little p, and then p is one of those letters. Is that big or small? Be careful. Okay, that's little r. So I know r, okay, so I want to find p, so I'm going to use this ratio. I know little p, I don't know it, but sine big P, that's 46, equals Q, I don't know. R, I'm going to need another piece of information here, right? Because I got how many variables? 3. That's not going to help me. What's this angle here? 180 minus 46 minus 75 is, what'd you say, Donna? Do we believe him? Okay. That's 59 degrees. And R is 440. Okay. I can do this. I only have one variable. How do I solve that for little p, the side length? How do I get rid of sine 46? Multiply it to both sides. Okay, so if you didn't have this on the top, you would have to cross multiply and then divide it by something. You have 2 steps instead of 1 step, right? Okay, so P is 440, come on, times sine 46 divided by sine 59 is, does that look reasonable for a length there? Sure, that's 440, looks a little shorter. Do I want it to the tenths, hundredths, nearest meter? 369. Sorry? Well, you're probably right, but you know what? Let's not worry about it. Okay. Let's round it to the nearest meter. Should be fine. Okay, I need Q. I need to get the perimeter. Okay, which ratio do you want to use? It doesn't matter because I know everything else. Q over sine of big Q is R over sine 59 times both sides by sine 75. Put that in your calculator. $496. Okay, so the perimeter add them up, and we should get 1305 meters. Okay. That should be enough, guys. I've done sine law 3 times.